This experiment is about to determine the capacitance of a given capacitor using Wein's bridge. And for this we need a post office box, which is the circuit is, my post office box is this is a Wein's capacitor bridge. Let me first disconnect all the connections. This is my post office box. I'll discuss it about this. And the second way is audio frequency oscillator, headphone, standard capacitor of known capacitor, experimental capacitor, connecting wire, etc., etc. Okay, so this is the complete apparatus for finding the capacitance of a capacitor using Wein's bridge, in which we have, this is the basically circuit. We have 4 arms, P, Q, R, C1, Cx and Rx. Okay, so P is, the P resistance is given here. You can see this is P. 1, 2, 3 knob is there. This is the multiplicative factor. So if I put this knob to 1, if I put this knob to 1, so multiplier is like 100, so this becomes 100. If I put this 200, this becomes 200. Similarly, the multiplication is 10. If I put this 1, this becomes 10, 20, 30. Similarly, this is multiplied by 1, so 1, 2, 3, 4. So first put all these knobs to 0. So this is P of the circuit P, and then Q. The Q is here, this, all these knobs. Then I have R, and you can see R here, R, these two knob, and I have Rx 0, 1, 2, 3, 4. So this is my Rx of the circuit. C1 here, capacitor is, C1 is fixed, is 0.10 microfarad, standard capacitor. Okay, this is load free. And Cx is my this Cx 1, 2, 3, 4 capacitor, whose capacitance we have to find out using these Wein's bridge capacitor. So we have to find the capacitance of these 4 capacitor using this circuit. D is the common one, which is at place of the detector we are going to use the headphone. Okay, so the first connection is the supply to this supply to the 1 kilohertz AC supply. So I'll connect this supply to this okay, this AC, and then second it is to, you can say this here, and then the unknown is, these are the 4 capacitors. So we can supply this one terminal of the unknown to here, and then this another terminal to, okay, the ground. So if I need to change the unknown, so I just have to change this here, here and here. Okay, this common will remain same. Okay, now in place of detector I have to use this headphone. This is my headphone, and I'll connect this headphone in place of detector. Okay, so this is, I'm connecting this place of detector. Okay, now I'm going to on this circuit. Okay, now the procedure of this experiment is like this. I have to, when I on this so procedure is this, that now let us on the circuit, and you can see all the knobs are at 0 position. So P value at 0, Q is 0, R is 0, and Rx is 0. And I have chosen this Cx, the first capacitor, unknown capacitor. Okay, so what I have to do is first put the value of P to 100, because the multiplier is 100. If I choose 1, so this becomes, the value of P is 100 ohm. So now when I do this 100 ohm, when I choose P 100 ohm, I note down the value of P to be 100 ohm. Now what I have to do is I have to vary the Q value. The moment I do this, I get a sound in my detector. Okay, so this in my headphone I get a sound. So by varying the value of Q, I have to minimize the sound which I am getting in my detector. So when I put this at 100, or maybe I have to vary this or this. By varying this, now for that moment when I put this at 100, I am getting a minimum sound, almost zero sound in my detector. Okay, so I will note this, that at for value of P100, at 100 Q value the sound gets minimized. So I will write it 100 ohm, the value of Q. Now the moment after this, I have to change the value of Rx from 0 to 1. And after doing this, I again get a sound in my detector. And now by varying the value of R, I have to minimize that sound. Okay, so using these two knobs. Now let us minimize this. Okay, at 10, I am getting a minimum sound. So now I will note down this value of R at which I am getting a minimum sound. So let's note this as 10 kilo ohm. Okay, now I will change the position of Rx from 1 to 2, and then I'll get again a sound coming in my detector, and then by varying the value of R, I'll try to find the minimum sound. So at 10, now let's vary it. So at 15, you have to hear it very carefully. So at 15, 10 here and 5 here. At 15, the sound gets minimized. So I will note it that at 15, this was for position of Rx1. This is for okay, 1, and this is for Rx2. P and Q are fixed for all these Rx. Now I'm changing the Rx1 and Rx2. Now I'll change the value of R from 2 to 3, and then again I'll get a sound, and then by minimizing the value of R, okay, at 20 I am getting a minimum sound. R value 20, I am getting minimum sound for Rx3. So this is for Rx3. I am getting in place of 18, I am getting at 20 the minimum sound. Okay, my value is 20. Similarly, for in the same way for R4, let us vary the R. So at 25, I am getting a minimum sound. So I'll write for Rx4, I am getting at 25, the sound is minimum. Now with this table, for when I put P value 100 and Q value is fixed for 100, for this is minimum for minimum sound, and by varying the Rx 1, 2, 3, 4 position, I'll get the value of R, this. So now I can calculate the value of Rx, because the Rx is RQ by P, I can calculate Rx. Okay, and then because C1 is fixed, I have already told you that C1 is 0.01 microfarad, and C1 is fixed in our case, so I can calculate Cx as C1 P by Q. So this is for, I can calculate C1 for all values of Rx, 0.01 microfarad. So this is my Cx. Okay, so this is first capacitor, this will be second, this will be third, and then this is fourth. Now, so the value of this first capacitor, which is Cx, is comes out to be 0.01 microfarad. Now let's move to the second unknown capacitor, change this from 1 to 2, and make everything again 0. Now, in the second case, I have just changed from first capacitor to the second capacitor, and then fix the value of P to 200. Now earlier for this first one, I had put it 1, and now for this second one, I'm going to put it 200. And now the moment I put 200, I'll get a sound in my detector, and then by varying Q, I'll have to minimize it. Now like 100. This is 100 again, it is for value of Q 100, it's minimized. So for 200 of P, I am getting 100 here. So 100 is for my value of Q. So now 200 is fixed and 100 is fixed for me in this case. For R equal to 0. Okay. Now I put value of Rx to 1, and by varying R, I'll try to find out the minimum sound. Okay, at 20 I am getting a minimum sound. At 20 I am getting a minimum sound. Okay, so I'll write 20, I am getting a minimum sound. Now I'll change the position of Rx from 1 to 2, and we'll try to figure out what is the value of R. So at 30 I am getting a minimum sound. So I'll write at 30 I am getting a minimum sound. Similarly, I will do for 3 and 4, and I'll get the readings accordingly. Okay, and then again we'll try to calculate, because C1 is fixed. I'll calculate the value of Rx and Cx as we did earlier for the first table. Okay, so in this case we'll get the value of my second capacitor. It has to be 0.02 microfarad. The average of this will get 0.02 microfarad. Now I'll change from second capacitor to third capacitor, putting all the knobs to 0 again. Okay, and then fixing P in place of 200 to 300, and varying Q, I have to find the value of the Q, and then again I'll have to change value of Rx from 0, 1, 2, 3 to 4. By varying R, try to find the minimum sound, and I'll get for 300 I'll get the value of Q and find the value of R and calculate all the things. Similarly, for the fourth capacitor, try to start the value of Q from 3 in place of 300, start from 400 and do the same procedure, and you calculate the value of Rx and Cx, and finally you'll get the value of C1, C2, C3 and C4, which is actually the value of capacitance of the capacitance of these 4 unknown capacitor using the Wein's bridge method. Thank you.